Here's integrated 3. This is your lecture part 2 for 4.3.2. I'm working on problem 4-73. It says if you wanted to use the relative frequency histogram, the one that we made in the last video, to determine the percentage of women in this sample who have run times between 22.5 and 24.5 minutes, you would add up the bars between 22.5 and 24.5. So 22.5, like you would add up, I don't know, this bar and then from here. But you can see that there's like a little bit of a problem with that. Not super easy to do. It says, since your histogram's not drawn conveniently with those as bins, you would have to redraw the histogram. So I'd want to redraw the histogram so that it ended, you know, so that each bar, like, so that there was a break right here at 22.5 and 24.5. But it turns out I do not have to. I don't have to redraw or change the bin width because I can use my model. It says, your model of the data comes to the rescue. So instead of dealing with these red bins here, I'm going to deal more with this blue curve. So this blue curve, remember, is my normal distribution curve. And it's just a model. It's not perfect, but it's a model of the data that's shown in the histogram. So what I can do is this little trick where I can find the area under the curve. So the area between 22.5, let me type that in. So did you see how I clicked the find the cumulative probability, the CDF? I'm going to go, I want somewhere between 22.5 and see how that looks like it's between 22.5, it's about 22.5, and then 24.5. See how it kind of did it? It put that in for me, and it actually calculated the area under the curve. So that can be interpreted as 67.585 or whatever percent. So I could say that's about, you know, 68, close to 68%. So that's useful because now I can say, look at, we're talking about race times for women, and I can say, hey, what percent of women run their race in between 22 and a half minutes and 24 and a half minutes? Oh, it's about, should I call it 68%? About 68% of the women. That might help if you're trying to organize a race or something. So this is a really handy model to have. And then in your book it tells you how to do it on a TI-83, but I'm just showing you here how to do it on Desmos. And if you didn't see how to get the normal distribution, that is in the previous video that I just made. So I feel like let's do letter B. So on 4-73 letter B, it says your model represents the percentages of women in the sample who have various run times. But it does more than that. Since the sample of 40 randomly selected women represents the whole population of women who run in 5K races, your model can tell you about the percentages of the whole population. If your model represents the whole population, what percentage of all women who run 5K races have race times between 20 and 25 minutes? So now they're saying 20 and 25 minutes. So there's 20 minutes, there's 25 minutes. I could actually just, you know, get a percent by counting up some numbers and dividing by 40 or whatever. But let's just use our little tool that we have here. So they said between 20 minutes and 25 minutes. So that's a lot. That's about 90, if I round it, maybe 97%, 96.6%. something like that. So that's how many women run the race in between 20 and 25 minutes. Letter C says, although the fastest time in the sample of 40 women was 20.6 minutes, the normal probability density function that you are using to model the population starts at negative infinity and goes all the way to positive infinity. So look, see our blue line? That's just our model that we're using, and it actually gets it's like kind of like an asymptote. It gets ever so close to zero, but it never quite gets there. So there's always a little tiny space under the curve, all the way from positive to negative infinity. That's what it's telling you in letter C. What percentage of all women in the population run faster than 26 minutes according to your model? So I want faster than 26 minutes. So that means I want to cut it off right here at 26 minutes and find the area under the curve all the way to the left. So that means on the very left, I have to actually type in negative infinity. Hey, do I know how to, let me start typing infinity. Oh, did you see that? So I started on my keyboard just typing the word infinity, and it put in the little symbol for me. And then my max, I think they said under 26 minutes. So there we go. And so that's like almost everybody. It's like 99.788. So we could say, let's see, your book rounded it to 99.8%. Letter D says, what percentage of women in the sample run faster than the mean time? What percentage of women in the population does the model predict will run faster than the mean time? So remember, the mean time is just the exact middle. That's what this model does. It sets up the mean as the middle. So I would say half of the women are faster than the mean time and half are slower. I don't know, do I want to type it in? Okay, so I'll type it in. So I want them to run faster than the mean time. So that means I want it to draw the line right here. So the mean time was, let's get rid of this number. Should show 50%. There's 50%. Okay. Okay, so the next problem is problem 4-74. I think I'm going to just make another video for it. So you'll have a part 3, something to look forward to.